All right, friends and neighbors, good afternoon. It's time for another networking video, and we are continuing our series with Packet Tracer. This time we're going to do something with network address translation, and we're going to mix in some ACLs. Okay, to start off with, we have a couple of topologies. It may look similar to the one that we were working on previously because we're going to modify that one. So we have the 1 NAT over here, the 2 NAT, and let's add some detail here. So if we were sitting at RIT maybe, you're in a lab there, this might be RIT. Now you can easily think of this as an ISP or your ISP, right? And then maybe over here we have, I don't know, the world. So that's the sort of the rest of the topology. Now we've got to give this some IP addresses, right? So clearly I've been fooling around here a little bit, but since it's going to be RIT, we'll say, in keeping with my convention, we're going to go IP address, I don't know, 192, we'll do 0254. And to make things a little interesting, let's use a class B, which is of course what this is. And we'll make sure we'll no shut the interface. And let's see. Oh, that's something we ought to do. Let's do this too. Let's go IP route 192.168.1.0. And that'll be going back to the inside, so it's 192.168.2.253. If I remember right, that's how we get there. So we're trying to get over here to this network via this router interface right there. Inconsistent route math. What did I do? Oh, whoops. There we go. Got a little crazy with my class B's. Okay, and maybe what we'll do is, I'm not even going to know if I'm going to worry about the world for right now. We'll just say that, that's sort of where it would be. It would be, whatever is upstream of your ISP. But really the business part of this is going to be right in here. So we're going to make this guy our NAT router. And maybe we'll add a label for that too. We'll say, well, you are going to be NAT or network address translation. There we go. Okay, so that's this router. Put that up. So that means that we are going to define what we're going to call the inside and the outside. So this is inside. And all of this out here will be outside. So we have these two clearly defined sort of sides to our topology. And so what I'm going to do on my router then is, first let me show you the routing table as it sits right now. So we have two directly connected routes, and we have one static route to get to the one network in here. And we're going to use that one here in a minute to show you how we can route at the same time as we translate, but we don't necessarily have to translate everything. So here we've got this directly connected network, and that's the one that we want to be our inside network. And actually, technically, everything to the right is going to be, or to the left, I'm sorry, is going to be inside, and to the right is going to be outside. So fast Ethernet 0/0, we're going to define that as our inside. So we're going to say int 0/0, and then we're going to say IPNAT inside. Okay? Now that also means that int f0/1 from the perspective of this router is going to be IPNAT outside. Spelling counts. There we go. Now, we haven't actually done very much yet. We're not ready to translate. We're just sort of defining what constitutes inside and outside. And what that really means is that we're going to say we're sort of defining or thinking about a direction that the translation is going to occur. All right. So what we also need to do is define how we're going to do our translation. Now, generally speaking, there are three major types of translation that you can do. You can say, well, I want to do one-to-one mapping. So I can say, well, I want this particular IP address to have this particular IP address on the outside when it does translation. And if you remember from network address translation, or if you watch the network address translation videos that I did, you know that once you do translation, the inside address that's being used disappears, right? It gets translated to the other interface, or to the other IP address that you're going to use. So we might say something like this. I could do a static mapping, so that's what I'm talking about here. And I might say IP NAT inside. Well, actually, let's do all the, all of our arguments here. So we're going to say what we want to do on the inside, and then what we're going to do on the outside. So I'm going to say inside, and then we get a source address translation. So if we take a look at the side here, really what I'm talking about right now is PC1. So I might say 192.168, in this case is 2.1. Well, what do? We got to tell 2.1, whoops. I suppose I got to add the keyword. Huh? Oh. I keep forgetting to do that. All right, so now we're going to do, we're going to tell it what we want to do. I got a little ahead of myself. All right, so here we go. Here's the inside source address that we want to do. So this is going to be this guy here. And then what do we do now? Well, we're going to say, well, what do we want to be? I'll put you back on this side. What do we want to be right here? Well, we know that the IP address of this particular interface is 129.21.0.254. So let's remember that. It's 129.21.0.254. Okay, so if that's my address, and I'm doing a static translation, I don't have to use that address. I could pick something else that might be recognizable. So if we say, what do we want to do? This will be the global address, or the one that's visible to everyone else on the globe. And so what we might say is 120. Now it's got to be valid on that network. So I might say 0, and let's pick something that might be recognizable, 99. Okay? And then we see what else we got, and we're done. So what I've just done there is created a static mapping between the inside and the outside. Okay. And that's pretty much it for translation of a particular address. And so what I want to do is, let's minimize this. And we're going to give this guy an address too. Whoops. Let's give this guy an address on the on that network too. So we got to change him from what he was before. What do we want him to be? We're going to be 129.21.0. We'll make it easy. 0, 1. And we'll change the mask for this guy too. And then its gateway, just to make our lives easy. Okay. Be like that. Now, here is what let's see, we got to fix this here too. Let's add a route. So you're seeing me do this all in real time from scratch, except for the first two networks here. Come on, router 0, and there we go. Okay, and what we got to do is route to the 129.21 network. So let's do an IP route. 129.21.0.0 255.255.0.0, and of course the via from this router will be this guy here. So that interface on that router. So 192.168 2.254. So we take a look at this routing table. We see that we've got two directly connected networks, and then we've got this static route for this other third one that we're currently using. And again, we might not use the fourth one. Now I could also have done a default gateway here, but I just sort of wanted to show you where all the addresses were being used. Okay. Now if I go ahead and from this PC, right, if I ping 129.21.0.1, that's pinging from right here to right here, right? Let me see if this works. And again, we got to update our tables and like that. So we'll just wait a second. Hey, look at that, it replies. But if we do our simulation here, and we go ahead and do this ping again, and what we're going to do, we want to see what happens on the outside here. So we see there's the packet going. Right, goes up to the router and down to the PC. Now that's the one I actually want. This guy right here. So if we open this, whoops, whoa. So if we take a look at this, we can see right here that the source and destination IP addresses are both on the 129.21.0.99 network. And so what that's telling me is that when I sent this message from the inside, this one right here, here it was, 2.1 to 129.21.0.1, when it hit the router, it was translated to this outside interface using the IP address that I specified in my static mapping, which was, of course, 129.21.0.99. So there you go. There's an example of a static one-to-one mapping. Now, I could, if I had a collection of hosts that were all going out and I wanted them to be translated, but I wanted to reuse some of the addresses, or I had a particular range of addresses that I had in mind that I wanted to use, well, I could specify a pool. Very similar to static, except it's a couple of more numbers. So let me add another note here. We just did static mapping. And then we just talked about pools, so we could do that. And then the last one that we're going to do is overload, and I'll show you an example of that. Now, before we go any farther here, we're going to go back to real time, and I'm going to try something else. I'm going to go from this particular host, right? And this one here is 192.168.1.1, and here we have 192.168.2.1, and here we have 129.21.0.1. Okay, so what I'm going to do is I'm going to go to that same address on the outside. So I'm going to ping 129.21.0.1. And we'll see if it works. See if I got my routing working. Okay, there we go. So that works. But hold the phone. Let's see what happens if we look on the outside. And we do our PC0. There we go. All right, so this is PC. Whoops. Whoa. So that's PC0 right there. Off it goes. Packet goes. Now, if we look at this packet, right, we see that this is 1.1, 192.168.1.1 to 129.21.1 or 21.0.1. And we just sort of keep this going. There's our routing tables working. Life is good. And then it gets to my NAT router again, and then it's on the outside. But what happened? Well, we'll let it go one more maybe just to, there we go. But if we take a look at this again, oh no, it did not get translated. And the reason for that is that I didn't tell it to translate that particular address. What I said was, If you see 192.168.2.1, I want you to translate that guy. And what this is saying is that everybody else is just routed. It's just routed. So we're not going to translate those at all. Okay. Well, let's do this another way. So I'm going to get rid of this translation. Right? I don't want to do it anymore. So we're just going to say no and get rid of the whole thing. So now we're just back to regular routing. Okay. So what I'm going to do instead is I'm going to say access list, I don't know, 8. Permit, and then I'm going to say 192.168.2.0, 0.0.0.255. All right. So that looks pretty familiar. It looks like just standard access list. But remember that access lists are just containers. Containers that connect, that have or hold a collection of rules that have match criteria. So this particular container has match criteria that matches anybody on this particular network. Okay? So now what I'm going to do is I'm going to show you another use for a container. And so we're going to do IP NAT inside, right? But then what could we do? We could say we're picking our source again, but what's our source going to be this time? Well, instead of a static mapping, I'm going to do a list. And the access list in this case is the access list that I just created, number 8. Well, now what do we do? Well, I'm going to tell it the interface that I want to do the translation on. Now I could, right there you can see that I could do a pool. I could specify a range. I'm not going to do that. I'm going to do an interface. And the interface that I'm going to use is that outside interface of that particular router. So it'll be int f0/0. And then I'm going to do one more keyword here. Oops. Got 2 interfaces there. f0/0. And then overload. Now we're going to see what that looks like here in a second. And maybe for this let's add another PC just for fun. Because you know, networking is all about fun. So we'll connect this guy here. There. Got to give it an IP address, of course. And it's on the 2NAT, so we'll go 168.2.2. And then our gateway 92. That's not going to work. All right, I like it. Okay, so there we go. So we have two nodes here on the network. And what I'm going to do is go ahead and ping that same outside address. And hey, look at that. It works. And let's try the same thing from here. Whoops. .129.21.0.1. Okay, good, good. So everything's working. But the question is, what did we just do? Well, let's open up our simulator here. And let's do our command. So this is from PC1. And maybe what we'll do is we'll add another label. Right? We got 192.168.2.2. Okay. And we'll bring you back up. So we're going to be pinging from PC1 first. You can see that right here, PC1. And we've got our simulator working, and we'll just go until we get one on the outside. There you go. Okay. And we'll go one more just to get it there. Okay. So here is our PDU. And we have these particular IP addresses. Let's see. Oh, okay. Let's see. Oh, yep. So I was momentarily confused here because I did the wrong. I didn't do the interface that I wanted to. So I'm going to change this a little bit. I was momentarily confused here. I'll show you and then I'll fix it. This says 2.254. I'm going, wait a minute, why is it 2.254? That's this interface right here. And that's because I specified that I wanted that interface to be used when I'm overloading. But of course, that doesn't really show us how network address translation works. So let me fix that. And then we'll be good to go. All right. So there we go. So what I want to do is F0/1. Forgot my own convention. All right. So now I'm using this interface right here. This one on the outside. So let's do our ping again. And so off we go. Okay, good. And we'll grab this one here. And looks good right there. So there's the address that's being used, right? So again, we're doing translation, and so the inside transmission that started as 192.168.2.1, it gets its header remapped and then sent on from 129.21.0254. But what also is happening here is we've got this PC that's part of this translation. So let's go to our simulation and let's do this guy too. He's going to ping the same address. And we're going, and we're going. There it goes. All right. We take a look here, and there it is. Look at that. By using a list that's overloading on a particular interface, we made all of the transmissions appear to have come from that particular IP address. And that's essentially what all of our wireless home gateways do. They do network address translation so that every transmission that comes out of your house or your dorm room or your apartment comes from the outside interface of your particular router. Okay, well, let's check one more thing here. We're going to ping from this guy, and we'll let those messages go. And we still have the responses coming back from the other ICMP, but we're watching this one come over here. And there it is. Okay, down to PC2. And we look, oh my goodness, it's not being translated. And of course, the reason that it's not being translated is because in the access list, I didn't say I wanted to translate that particular range of addresses. So what I did was I translated some and I NATed, and I straight up routed the other ones. Well, how could I change that? How could I fix that? Well, if I wanted to, I could edit my access list, right? I could say, well, let's take a look at our access list. Show access lists. I could change this access list to include the 192.168.1.0 network. Now, I could do that by changing the mask. I could. Or I could just add the new network to that access list. And I think that's what I'll do. Let's see. Yeah, there we go. So all we did was add it. And we'll make sure that it's in there okay. Okay. So now what happens, so we'll close our simulator again. We'll make sure that we're ready to go. All right. So we'll go back to our simulation. Oops. There we go. Let's clear that out. And off we go. So that's going. We can see it. We're orange this time. going all the way across. We're routing. It's going up to the network address translation box, down to the switch, and then finally to PC2. And then what does it look like? Hey, look, it's now translated. Why? Because I added that particular network to my container. There we go. Now maybe it's worth looking at what the response is from PC2. Who's it talking to? Well, it thinks it's talking to this particular IP address, but of course it's not. It has to go all the way back. Well, let's see if it gets all the way back. Oh, it looks pretty good so far. Now, what does it look like on the inside? Well, it's 129.21.01. That's that outside host. But it's back to using this regular IP address, or the original IP address. How did that happen? Well, on our router, the router actually keeps a table that shows you the inside addresses and the outside addresses. So all the transmissions that I've been doing are recorded here. And so we've got an outside local and an outside global, and then we've got where we came from and what we were doing for our translation, what the world was going to think the translation looked like. And so what happens is we look at this transmission and we go, all right, where were you starting out and where were you going, right? And then what am I going to use for your IP address? And I'm still going to the same place. So this is one of the cases where we actually change the content of the IP header. In routing, routers don't usually mess with IP headers, but this is a case where they certainly do. So the header checksum would have to be recalculated, and we'd actually rewrite the IP addresses. So it goes out, and then when it comes back, the router says, oh, I got this. Where were you supposed to be going? Oh, you were supposed to be going to this destination, so I'll just remap the header again. And that is how network address translation works. So it's all here, once again, in the tables. There we go. So just to sort of recap this, right? We've got this network address translation box. We have a couple of ways of doing network address translation. And we're using, in the end there, the same kind of container that we were using for permitting or denying traffic, or actually removing traffic from the network, as you saw when we did extended and standard ACLs. But in this case, we're using ACLs just as a container, and the container is being used to decide who gets routed and who gets translated. And so the way that translation works is that if you are being translated, your traffic goes out through the router that's doing the translation. The router builds a table that says, here's your original inside, here's your original destination, here's what I'm going to use for you, and here's the same destination. And when it comes back, the router then reads that same table and remaps the IP addresses again. Well, I think that'll do it for this episode of Hey, Let's Build a Network, or a packet tracer, or whatever you want to call it. I hope you got something out of it. Thanks very much for watching. Thanks for listening. May your packets always reach their destination. And hey, it's networking. You can do this.